Hey everyone, welcome back to another Leetcode video where today we're going to be solving min-cost climbing stairs. So this is actually another dynamic programming question, and it's based on the linear uh, transition dynamic programming type problems, if you know what that is. And essentially, it's very similar to actually another problem that we solved previously on this channel called climbing stairs. It's pretty similar to that, but except so we're given an integer array cost where the ith step is in the cost array is essentially like the cost of that step on the staircase. So you kind of have to pay this sort of like entry fee to enter that staircase, and then from there you can kind of climb one or two steps, and that's very similar to the other climbing stairs problem. And we're also told that we can start from either step of index 0 or step with index 1. So we can stop from the very bottom or like the second sort of step. So, for example, in this solution, we have three steps, right? So, in example 1 is what we're looking at right now. And here we have three steps, right? So we have step 1, step 2, and step 3. And so, essentially, we can start here. So this is, I'm just trying to see if the top is included. Okay, I just realized the way they're doing this is if you start here, then this is 10, and then this is 15, and then, okay, so this is 20, and then 20 is the top. Actually, no, I think the top is here. This is the top. Yeah. Yeah, okay. That makes sense. So yeah, so here, so this would be step of index 0, step of index 1, 2, and then this is the top. So here, essentially we can start at index 0, so which would be 10, or of index 15. So if we start at index 0, so let's say like we start here, and then we pay the cost of 10, and then we can either move one step forward or two steps forward, right? So then if we move two steps forward, then we have to pay a cost of 20, and then we can move to the top. So then in this case, the total cost would be 10 plus 20, which is then 30. But we have other options, right? So let's say we start at 10 and then move to 15, so we pay 15, and then we move to the top. This is actually a more optimal solution because in this case, we're just paying 10 plus 15 to be 25. But can we do better? And the answer is yes, we can. Because we don't actually have to start at index 0. We can start at index 15, or index 1, sorry, which is 15. So if we start here, we just have to pay 15, and then we can just take two steps and then move to the top, right? And then that's free. So then here, our total cost is the minimum cost that we have is 15. And so we can actually solve this with dynamic programming. So here, using the tabulation method. And actually, there's like different ways to solve this. There's an O of n space complexity that I'll be going over and doing the code first, and then after that, I'll talk about the O of 1 space complexity. And but for that, you have to understand the O of n space complexity first. So, for example, we'll take the first example where cost is 10, 15, and 20. So, in this example, if we make a DP table, we want to initialize the table to be n plus 1 because we have 0, 1, 2, 3, right? And notice like this is n plus 1. And at this DP table, we can essentially take in very similar to climbing stairs, where we can take in the previous element, and then also the second previous element, so that's n minus 1 and n minus 2, and add them together to get the minimum cost, right? So at dp0, our base case, we initialize it to be 0, and then we also initialize index 1 to be 0 as well. And the reason we do that, so at dp0, we initialize it to be 0 because at the first step you're not paying a cost, right? You're at this first step, and same with the second step. You're just or if you're starting at index 1, you're just simply just like, it's just your start point. You're not paying a cost to start there. That is just your start point. And then after that, we have two options. So we want to fill this table bottom up, but we want to fill it with the minimum cost at each step. So at each ith step, right? So in this case, at option 2, the way that it is we want to take in so we have two different options, right? So we have option 1 to be the previous element in DP, and then the previous element in cost as well, right? And that's option 1 because um, the cost is going to give you like, oh, how much did it cost to get to that step, where DP of I minus 1 is giving you the previous sort of like minimum cost, and you can add that to your ith position. So in this case, in I of 2, our DP of the previous element is actually 0, and then at I equals 2, essentially our DP, our cost, was actually 15. Yeah. So here we can add these together, and this is option 1, right? So the total cost is 15. Now we have option 2, which is dp of I minus 2 plus the cost of I minus 2. So in this case, we're also initializing it to be here. So in this case, dp of I minus 2 is, so we're at 2, so that means that's at index 0, so that is 0. And of cost of I minus 2, so here, that's also at 0, because if we're at I equals to 2, that's 10. And here, we get both of our options, and then here we just want to return kind of like the min option, and that's what's going to be placed at dp of I, which is 2. So the minimum of 10 and 15 is 10, so we're going to put in 10, and it's going to be the same thing for I for dp of 3, right? So here, so for option 1, for the previous element of 3, this is 10, and then the cost of I minus 1, so that would be 20. And then you add them together, we get 30. And then here, for option 2, dp of I minus 2, so if we're at 3, that means we're looking at 1, so that is 0. And then the cost of I minus 2, so 3 is technically here, but we don't get an out of bounds error. And then I minus 2, we're looking at 1, so that is 15. So 0 plus 15, that is 15. And then again, we just want to take the minimum of this. So the minimum of 15 and 30 is 15, and that's what we initialize it here. And now, since we filled up our entire DP array bottom up, we just simply want to return 15, right? Like the last element of your DP array. And so that is actually the correct answer, and that is the total cost. So I'll code up this tabulation O of n time complex O of n time complexity and O of n space complexity first, and then we'll return back to the drawing board for the O of 1 space complexity solution. So here, to implement the O of n time complexity solution, essentially we want to create a DP array. And we're going to initialize all the values to be 0 and then multiply that with the length. So in our case, it's n plus 1. So we can just get the length of n, which is the length of cost. And then here, we initialize the DP array to be the length of cost plus 1, or in other words, n plus 1. And although this is not necessary, I'm just going to put this in for clarification. So our base cases, so dp of 0 is going to be 0, and then dp of 1 is going to be 0. Although, because we initialized the array to be 0, like this is not necessary at all, but I'll just put it in just for good practice. And then now we want to iterate through our DP array. And here we actually want to start off actually at index 2 and then go on to the length of our DP array. And just like in the drawing, basically we have two options, right? We have the first option, option 1, to be the DP of I minus 1, so the previous element, plus the cost of I minus 1. And then option 2 is the second previous element, plus the cost of I minus 2. And then, so we're going to initialize the DP array at I to be the minimum of option 1 and of option 2. And then lastly, we just want to return dp of n. And this should work. Just like that, it works. So time complexity of this is O of n, and the space complexity of this is also O of n. So let's return back to the drawing board where I'll talk about the O of 1 memory complexity solution. So to implement the solution in an O of 1 time complexity, we can just full on get rid of our DP array and do everything in place in our cost array. So the first thing that we want to do is actually append 0 to the end of the cost array to represent the top floor. Right, so this is the top floor. Now, what we want to do is we want to iterate backwards, right? So we want to start at actually the third last step and iterate backwards through there. So for example, if we start at 15, and then we can kind of do the same thing in where we get option 1 and option 2. So in our case, option 1 would be basically the cost of at index I plus the cost at index I plus 1. Right? So in our case, option 1 is 15 plus 20, which is 35. And then to get option 2, we want to iterate. So it's going to be like if we skip a step. So if we take 2 steps, right? So here, if we start at 15 and we take 2 steps, right, I plus 2, so this is 15 plus 0, that means we're already at the top floor, and that's 15, right? So then, cost of I, we're just gonna update it with the minimum of these options. So the minimum of 35 and 15 is 15, and well, this is already 15, so we're just gonna leave it. And then since we're iterating backwards, so because we're filling bottom up, we're now at 10. And now here, option 1 is going to be essentially itself, so like 10 plus I plus 1, so that's 15. And then option 2 is going to be 10 plus I plus 2. So in our case, it's going to be 10 plus 20. And then we can update it. So 10 plus 15 is 25, and then 10 plus 20 is 30, right? And then the minimum of that is 25. and then we just update the cost at the position I to be the minimum. So in our case, this 10 gets replaced with 25. And then since our pointer reached the end of the array, we, at this point, because in the question, it said that we can start from step with index 0 or step with index 1. We can, so this will be our two starting points, so then we can just return the minimum of these two values, which in our case, the minimum that is going to be returned is 15. And that is the correct answer. So let's go back to the code and we'll implement this. So just like in the drawing example, the first thing that we want to do is actually add the top floor to our cost, if I can spell properly. And so basically all we have to do is append 0 to our cost. And then after that, we just want to iterate backwards, starting at the third last position. So the way we can do that in Python is we can initialize like a for loop like this. So we want to start at the third last position and then go all the way up to the first position, but then it's not inclusive, so that's why we go up to -1, and then we want to take -1 steps backwards. And in this case, we have our option 1 to be essentially cost of I plus cost of I plus 1. And then in option 2 is our cost of I plus our cost of I plus 2. And then your actual cost of I is gonna be like the minimum of your option 1 and of your option 2. And I know like here you can like simplify this, and rather than making like extra variables, you can just put this all in like one line, but just for readability wise, and to make the code more modular and for it to be like easily read, I'm just doing it this way. And then once you're done iterating through that for loop, all you have to do is return. So because we can start at index 0 or index 1, you just want to return like the minimum of cost of index 0 or the cost of index 1. And then we can run that. And just like that, it works. And so the time complexity of that solution is O of n, and the memory complexity of that solution is O of 1. So I really hope you guys enjoyed this video. I hope everything made sense. If you liked the video, please like and subscribe. And leave a comment down below which problem you want me to solve next. All right, have a nice day.